A hard candy comes a long way sometimes when you have a bad day. Okay, let me go.
They like playing pranks on each other. Last year, we used to put pop cans in people's wheel wells, drag their tires. So like you'd be driving away and all of a sudden you hear that. You'd be like, what the heck? They pull up, stop, get out, and look around, trying to figure out what you scratched or something. Pop can.
Oh my God. Okay, gentlemen, happy Friday. So if you just go please to chapter 7, page 155. This chapter talks about motors and appliances. We're going to define, you guys are familiar with motors. You have an air handling unit, a chiller, you have exhaust fans, Adam, that you guys have designed for it. So this is nothing new. So we'll talk a few things about different type of motors and appliances that we're going to use for this application. A few things I want to emphasize in this chapter, guys. How does the code define the word appliances? Defined in NEC code book, your refrigerator, your microwave, your all these are appliances and treat them differently. So how it's defined by NEC code book, utilization equipment, appliances are utilization equipment, how that code defines utilization equipment, and methods of installation and wiring for these appliances in terms of brand circuits and feeders. You know, let me summarize what we do, guys. As electrical designers and electricians, people come to us every time there's a machine, any type of machine, an appliance, a fan, what's not. They come to us to design a system for it. And you know what we do? We do three things, really, in the whole building, and they pay us to do that. We design a service interest conductor to a building, power coming in with all the conductors and what's not. Then we do feeders to go from panel to panel. And then from the last panel, we go branch circuit to feed these equipments, be it light, be it receptacles, be it air handling units and what's not. And a long time ago, when you have a mixer, these commercial mixers, people got sick of leaving their fingers there when they clean it. While they're cleaning it, somebody accidentally will go energize these appliances, and then people will lose hands and fingers. So the Smarter Than Chad got together a long time ago through OSHA and say, hey, if you have an appliance that can rotate and can chop people's fingers and hands, we want to have some type of a disconnect to disconnect it. So we'll talk about the disconnects. Grounding. Every time you talk about electrical equipment, guys, I told you many times that you probably remember that there's two hazards associated with the science of electricity, right? The shock hazard and the arc flash, arc blast hazard. The shock hazard, the reason why we ground system, because we're going to protect people from a shock hazard. So if you imagine you have a water heater, appliance that's a water heater, you have to ground it. You know why? Because if you're holding on that water heater, do you really want to be electrocuted if accidentally the electrical water heater frame to become energized? So grounding is essential for all the appliances. Then we'll talk about, guys, the branch circuit size, um, conductor size, branch circuit conductor size, the overcompression device size for motors appliances. And there's one little thing, I don't know how many of you guys have done that, type 2 and type 1 protection. When you have a machine, there are two ways of protecting this machine, Adam. If the machine is very important, they protect it with type 2. If it's not too important, they protect it with type 1. We'll talk about the difference between type 1 and type 2 protection in a second. Here's the one, the NEC, guys, how the NEC defines appliances. A utilization equipment, standardized sizes, refrigerator, microwave, water heater, that's where you standardize sizes, or types that is installed or connected as a unit to perform a specific function. So standardized sizes, manufactured, a fancy name for a refrigerator, a microwave, a garbage disposal, a water heater, range, you name it. And all these commercial mixing equipment, dough mixers and what's not, all these are defined as appliances. Who cares? Then the secret book, guys, I'll have a whole article, Article 422, dedicated to these standardized equipment. These standardized equipment. Um, so The single most important thing is we need to know about these is typically they are marked with two very important things. You have a dough mixer. You go buy a dough mixer and you install it here, done with. Simple things there when you have a commercial dough mixer. Right on the nameplate, they will tell you the name, they will tell you the overcompression device that this mixer need, 20 amp, 50 amp, what's that, and the conductor size, right on the appliances. So that's, and then of course it needs a disconnect because you don't want to mix people's fingers with the food too. You need to disconnect it. So they have to tell you either it has to be plugged in, so the plug will be your disconnect, or why don't you provide a disconnect right within inside of the equipment. As simple as that. That's your appliances. If it's not marked, then you have to go and size the overcompression device exactly like any other feeders from Article 240. Article 240. Grounding for appliances. Appliances must be grounded. All appliances must be grounded, guys, with very, very exceptions. If it's double insulated, there's an exception, but they have to be grounded. Why grounded, Karen? Because we want to minimize, if not eliminate, the shock hazard, the electrical shock hazard. That's why we ground systems. No exception. So if you have a dishwasher, microwave, refrigerator, dough mixer, deep fryer, any type of these appliances, they have to be also grounded. So if they're three phase, they have to have 4 wires coming to them, 3 phase and a ground. If they need a neutral, they will have 5 wires coming to them, 3 phase, neutral, and a ground. Does that make sense? All of them, typical. Disconnects, very, very important, guys. For permanently connected appliances, you are to have a disconnect for these babies. The disconnect, like your dishwasher, or all these appliances that you can think of, dough mixer, have to have an appliances, a disconnect. The main reason for the disconnect, you're looking at it, guys, right in here. The main reason for the disconnect is to physically, mechanically isolate the system so you can work on a safety. Lockout, tag out procedures. When it's energized, you de-energize it, lock it, tag it, work on it safely, because Derek, believe it or not, we got people lost fingers and hands inside these appliances. We killed people inside these appliances. There's stories, I know of a story where there was a kid inside a big mixer, he got inside the big mixer to clean it, right? And somebody started that mixer while the kid is there, completely cut it into little pieces. So it's you can imagine why disconnects are so important. It's not just electrically speaking, guys. All these machines that they do so many functions, think about it. Every single manufacturing plant that we have has tons of machines that has to be cleaned, worked on, maintained, troubleshoot, what's not. So when you go lock this machine, guys, you put it here, you re-energize it, you lock it, you tag it with your own lock. Nobody else other than you can energize this equipment. So your chances of surviving is much, much higher. Okay, so that's your disconnect. Everybody knows what a disconnect. If your appliances has motors on them, then you have to adhere to the rules of the motors. If the appliance doesn't have a motor, for like water heater, does not have a motor, right? You have to have a disconnect with inside of it. Done. If it has a motor, then there's rules of a motor, which becomes these disconnects have to be horsepower rated too. Okay, so connected appliances at more than 1/8 of a horsepower, this means must be within sight. So if you have a horsepower within it, then you have to have the disconnect within sight. For the most part, guys, almost all appliances, all motors have to have a disconnect within sight of the equipment. The only exception of that one, small fans, little motors, and what's not. That's the only exception for that one. Appliances, guys, can be an integral switch with the unit. So I have my appliance here. They have a little tiny switch next to it. That will qualify. You have an electrical water heater, Brian, and right next to it, the manufacturer provided a disconnect that disconnects all the energized equipment. That disconnect switch will qualify as a disconnect. Who cares? You don't need to go put another disconnect next to it. I can't emphasize, Karen, when you guys deal with the electrical equipment, especially the 3-phase equipment, always ask yourself, number one, do I have a branch circuit, an overcompression device, and a conductor to feed it? Number two, do I have a disconnect to disconnect? Number three, do I have a controller to control it? These are the questions that you're going to ask every time you're laying out equipment. You were asking me the same thing yesterday, Chad. It says it need a disconnect. Do I need to put the disconnect? Yeah, but if they say you need a disconnect, this means the manufacturer have not provided a disconnect. You just throw a disconnect like this baby there right next to it. If it need a controller, remember that we was talking about magnetic starter, Derek, yesterday? If it need a controller, this means the manufacturer have not provided a controller with it. So the cheapest controller that you can throw on any machine, guys, is a NEMA. Throw a NEMA 00, throw a NEMA 9 on one of these appliances. um, Okay. Cord and plug connected. When you guys, I don't know if you go down to the cafeteria and eat most of the time. If you go there, watch all these in the cafeteria, all these deep fryers and ovens and what's not. Almost all of them have a plug-in. These are appliances, right? How do you disconnect them? Where's the disconnect for all of them? Believe it or not, you unplug that baby, and that's your disconnect. So the plug can act as a disconnect for equipment. Most of major three-phase equipment, guys, are hardwired. But if they're plugged in, remember, a disconnect, a plug, act as a disconnect means. Acts a disconnect means. And you know what they do? What OSHA requires certain appliances, guys, bigger equipment. You have that you unplug it. Then they have a little cap to make sure that nobody's going to plug that big machine while you're working on it. You first unplug it, and they have a cap. Put the cap at the top of that plug. Lock the plug, so now the plug cannot be plugged in. And that will be the locking mechanism. Lock and tag it for the plug. So that's for major equipment. Okay, so that's basically, so summary, my friends, every time you are given an appliances or a motor or an appliances that has a motor in it, always ask yourself, do I have a disconnect within inside of that machine? Not, if not, then you have to install a disconnect within inside of the machine, the motor, its machine, and its controller. A couple of things, guys, about motors. The reason why we single out motors out of all the things, because motors, if almost every appliances have to have some type of a motor in it. So for motors, in order to work on these motors and maintain them, you need to disconnect them. Here's a couple of things that could happen to your motors: abuse, lack of oil, bad bearing, and what's not. That all lead into motor failure. Who cares about motor failure? A lot of smarter than Chad people, when they get into a building like Dunwoody, they put the building into a maintenance program that annually, guys, they check these equipments and they go maintain them. So when you check them, you have to check them de-energized. So that will require you to have Mr. Disconnect. So that's where disconnect is tied directly into maintaining the equipment in order to minimize the failure of these equipment. If you have a disconnect that disconnect motors, the motors be provided with means to disconnect motors from the electrical system. Every motor must have to have a disconnect, like we said. If it's disconnecting a motor, it has to be horsepower rated. For example, if I have an air handling unit and my air handling unit, guys, is 50 horsepower, and I want to grab this disconnect from my air handling unit, this disconnect has to be two things: amp rated and horsepower rated. So that will be saying, let's just say this will be a 100 amp disconnect and a 50 horsepower rating. The reason, Karen, that they rate the disconnect with horsepower is because, say the air handling unit is up and running, right? And Chad decided, you're not supposed to do that, but say that air handling unit is running and you decided to disconnect de-energize the air handling unit using the disconnect. If the disconnect, guys, is not rated to interrupt the flow of energy that's equivalent to the power needed to power this air handling unit, that disconnect will blow up in your face. Any comments, guys, about horsepower rated for equipment and disconnects? When we size the disconnects, you have to be aware that disconnects have to be amp as well as horsepower rated for motors. Okay, for disconnects, guys, for machines and motors have two rules. Rule number one, I'll show you in a second. It has to be within sight of Mrs. Controller and within sight of the equipment as well as within sight of Mrs. Controller. So your disconnects have to be within sight of your controller as well as within sight of the equipment. So I'll show you a couple of pictures in a second here. Start and stop push buttons like these. These start and stop push buttons, guys, do not qualify as a disconnect. Start and stop push buttons do not qualify as a disconnect. Okay, air conditioning, all your air conditioning, guys, the condensing unit, Adam, either the condensing unit, which is air conditioning, has to have a disconnect provided by the manufacturer, or in our project, Derek, what did you do? I told you to throw a disconnect right at the equipment, right next to the equipment. Has to have a disconnect. Has to be rated to handle the energy used to power this equipment, as well as the current that's going to go through this equipment, which is basically the energy. Um, so that's all air handling units have to have a disconnect, same thing with inside. Exhaust fans, if you have a small fractional horsepower like exhaust fans, guys, a single pole snap switch can act as a controller and a disconnect. For example, Brian, in the bathroom, the bathroom that we have in our project, guys, you have a fan in the female and male bathroom. The disconnect, the switch that you have to turn that fan on and off will act as your disconnect as well as your controller for fractional horsepower motors. Here's an example. Here's my fan right here coming in. We're supplying it. I have a controller here. That baby acts as a disconnect for this mission, for this fractional. Do you guys familiar with the fractional horsepower? These are less than 1 horsepower. These are little horsepowers. Machines, not the smaller the horsepower, the less dangerous the equipment is. So you can use a snap switch like this one to disconnect them. Okay, so why do we have a disconnect? Disconnect to minimize the hazard, guys, of electrocution plus arc flash, arc blast, so you can lock and tag the equipment. You need also for every appliances, guys, or every equipment, you need a Bryant circuit, basically a Mr. Conductor right in here. That conductor almost always for appliances and motors is 125%. I told you, Brian, when you guys leave chat, if anybody said, I have a Bryant circuit, size this Bryant circuit for me. And here's the amp for it, 100 amp. If you guys don't know anything about it, what do you say? You say, oh, 100 times 1.25, that'll get you 125 amps, size the conductors. If you say that, you are right 95% of the time. 90 to 95% of the time. Always consider it continuous load. That's why the 1.25. Get the amps, multiply by 1.25, size your conductors. So for appliances and motors and what's not. Color code for motors, guys, and Bryant circuit, they follow the same. When you have motor Bryant circuit, they follow the same rules as ungrounded conductor, grounded conductor, and grounded conductor. For example, for the neutral, we use the white or the gray or white stripes on other than gray or green. For ungrounded conductor, you can use pink or blue or red, any color that's not gray or white or green. For grounded conductor, we always use either bare or green conductors. Same rules for other applications. Motor overload for motors, because so we have when it comes to motors, you guys have done it with me. The first thing you need to do when it comes to any machine, you need to have an overcam protection device for it. Then you have to have some type of a disconnect. Then you have to have an overload or a controller. Then you have to have an overload. Then you have to have your machine. So that's how. If you guys look at this, this is a typical controller for a motor. You start with your disconnect. The power came in. Disconnect. You have your overload protection here. You have the controller and you have the overload protection device. Then you have the controller and the overload right underneath it, and the controller right into it. That's exactly what they do for any motor. They can either put them in a box, that's called a combo starter, or you can put them in a panel, that's called an MCC. Okay, the overload. We talked about overload before, and you guys sized it for us. The overload will protect your motor from being overloaded. How do you overload a motor? The motor is supposed to give you 15 horsepower. Now you're pulling 20 horsepower out of it by adding more mechanical load on this machine that this motor is driving. So you need to put an overload protection to protect that motor from overloading. Relays is the most common ones, guys. They have electronic solid state relays, or they have heaters, and they are manually or automatically. You can set the manual automatically. So when it comes to overload protection, you have two options. I'll show you in a second. You have electronic overload protection, which is the most common now, or you have the thermal overload protection. A tiny little thermal heater. It heats a device, it melts, it opens it to protect, to de-energize the equipment, to protect the equipment from being burned. I'll show you what happens if you don't have it. We have nice pictures, guys, in this book. What happens if you don't have an overload protection? Insulation. I'll talk about insulation, guys. The guts of the motor, guys, is made out of magnetic wire with insulation. The higher the temperature insulation of a motor, the better the motor, the more the motor can handle heat. Derek, when I teach apprenticeship, I always say, start with this word. Enemy number one of electricity is heat. You see that number 14 conductor? I can make number 14 conductor can carry 100 amp if I don't care about melting the insulation and smoke coming out of it. You know, so heat is enemy number one of electricity. So if the guts of the motor start heating up, you burn the motor. So what the smarter than Chad years ago, aren't you guys amazed how there's so many people like we talk about Einstein. There's so many Einsteins that invested the insulation of these equipments. They tried different type of insulation, 250 degrees Celsius. You know what 250 degrees Celsius? It's very hot. That can reach before these insulations start melting. Talk about a 3M coming with a material that can handle 350 degrees Celsius. That's burning hot, you know. So they came up with the insulation classes, guys. I'll show you. I have a slide that has the classes. The higher classes means higher insulation. Higher temperature means the motor is robust, can handle more heat, basically. And we'll talk about these one. And there's also service factor. If something you talk about, guys, the service factor. Service factor is a multiplier that you multiply by the horsepower to give you extra horsepower that the motor can deliver. So if your service factor is 1.5 or 1.15 and your motor is a 100 horsepower motor, this means this motor is capable of delivering 15 horsepower more than what it's rated for to handle the air rush, or to handle more load on that motor. So that's your service factor. Your service factor, and it has to do with sizing over or load and so forth. So we talked about the service factor, insulation. So overload, this is just talk about how the current flows in a single phase motor. The current in a single phase motor, guys, go in the hot back to the back on the neutral. So if you interrupt the hot conductor, the ungrounded conductor, you will interrupt the flow of energy. So you need only one overcome protection device in the ungrounded conductor. There's something called single phasing. I'll show you a very nice picture, guys. Single phasing. I want you guys to remember single phasing, Karen, is you have a 3-phase motor, and all of a sudden you lost one phase. Why would you lose a phase? Here's a reason why would you lose a phase. How about the electrical utility? Where's Brian? How about Fleming Excel? Because one of their fuses, there are 3 fuses, one of them blew up on the transmission or distribution line, and the other 2 are still running. High single phasing, right? The primary and the utility transformer cutouts are open. One of them are open, or 2 of them are open, single phasing. How about bad termination? You have lugs, guys, and one of them got loose and opened. Anywhere inside your power system. That's single phasing. Open splices, same thing. Broken conductor, burned open contacts. Contact is a major part. See that contact, guys, when they open and close here? Now what happens if it malfunction over years and one of them will not close, right? Only one. 2 of them will close, 1 will not close. You got yourself a single phasing. Now what happens if you have a single phasing in the motor, guys? Bad news. Single phase or 3-phase motor will be bad news. Here's what happened, guys. Look at this. This is a picture of, I have an open phase, phase A. I lost phase A, B, and C. For whatever reason, utility or contactor or fuse or what's not. In a case like this, if you guys look at this, the other Now this conductor is carrying 0 amps. The motor was supposed to have a 10 amp. The other conductors, guys, will be carrying 173%. Here's how it goes. In a three-phase motor, if you lose one phase, to compensate for the loss of the phase, every other phase will be carrying 173% of what's rated for. Does that make sense? So, for example, this was a 10 horsepower motor. Now this is carrying 17.2 and 17.2 instead of carrying 10. Why? To compensate for the loss of the other phase, and the motor will continue to run. There's one little problem. Now you're overloading these coils, right? They have more current than what they're rated for. So can you see the overload here? Your overload is rated for 12.5. You have 17.3 coming out of it. It will open within 10 to 20 seconds. That's why overload is so important, guys. It will protect you from single phasing condition. I have more examples to show you. This is talking about strange things happen. I'll show you guys in a second. If you have if you have a single phase in your system and you have a big fat motor up or running here, you know what happens with that big fat motor, guys? It can generate a third phase that can start other single phase motors. So it backfeed, like creating another phase if it's lightly loaded. So if you're in a plant, you could lose a phase and you don't even know that you lost a phase if you're loaded, if your system are lightly loaded. Be aware of this one, Derek, when you become a big engineer and what's not, and you go there, you could be in a plant and you lost a phase and the equipment is still functioning for the most part appropriately if the equipment is lightly loaded. What's a lightly loaded, guys? I have a 10 horsepower motor and I'm only pulling 5 horsepower out of it. So if you double the load on it, take this. If it's rated for 10 horsepower and then you're only pulling right now 5 horsepower out of it, and if you single phase, you're going to double the current in it. When you double the current, you're still within the working parameters. Do you see how nothing is going to trip? So be aware of that one.
Here's the video of the guy who sets up he's got a three-phase system in his garage, but he uses ghosting. So just kind of.
Yeah, that's exactly. Yes, that's exactly what they're saying. Yeah. You can, if you go online, you can find a lot of people who can hook up 3 single-phase motors to run a third phase, create a third phase. A third phase, guys, is how do you create phases? You have coils. You manipulate the magnetism to create a third phase. So, and what are motors? Motors are coils. So you could easily create another phase. Now, is this phase? Here's the question: is this phase as good as Excel phase that they give you? Absolutely not. Is it efficient? Not. Does it work? Yes. Does it work efficiently? Absolutely not. Does it give you the full power? No. But would it run slightly? Yes. Yeah, small loads and so forth. Huh? Yeah, the phases are come. Okay, take this. Unbalanced voltage. Now that's a problem with Excel. The equipment, guys, can you put D0 here? The equipment are rated to run at plus or minus 10% of its rated voltage. In order for your equipment current to run, if the equipment are rated for 480, you can give it 10% higher or 10% lower, and that equipment should work properly within that range. That's set by NEMA for most equipment. If you increase the voltage higher or decrease the voltage lower, guys, the performance of your equipment will suffer, and I have an example that shows you in a second here. We can use dual element time delay fuses as a good protection as a backup overload protection for motors. Dual element time delay fuses, they use them either alone or as in addition to a heater or an electronic overload to provide an overload protection for motors. And we'll talk about this one. Ground fault short circuit, guys. You have to provide the short circuit protection ground fault. That's all coming from table. Do you guys remember that table for 430.52? We looked at it. When you go there Adam, your options are either non-time delay fuse, dual element time delay fuse, or circuit breaker, inverse type circuit breakers, or instantaneous circuit breakers. That's to protect you from the short circuit and the ground fault, not the overload. If you guys remember, and you've done that, if you hit a non-standard, if you guys go there, it tells you go to the next standard. When you hit non-standard, go to the next standard. We've done examples, many examples for that one. The motor will not start with this fuse or breaker. You can even go larger. So first, you go to the next standard. Second, if your motor still doesn't start, keep tripping, the code allows you to go even larger to a limit, though, to a limit. And of course, with that one, you always check the manufacturer overload relay tables for maximum size or type of overcome tissue device that you're supposed to use. There's the starter current, the lock rotor current, or the lock rotor current, the starting current. All these are a function of so-called the code letter, guys. The code letter decide how much starting current you're gonna get. When you energize a piece of equipment current, the equipment up to 10 seconds will typically suck out of the system at least 6 to 10% more amps than what it needs to run. That's called the starting current. We talked about this one a couple of times. The higher the code letter, the higher the starting current. The higher the code letter, the higher the starting current that's going to have. So code letter B is have high starting current than a code letter A. And all this information, ladies and gentlemen, is coming from this table. And I assure you that you guys have used it before, and I assure you that you will be using it next project too, because we're going to be using this table too. There's something called design letters or design designation, A, B. We have B, C, and D. The design letters, guys, or design type for motors B, C, and D. Let me tell you, very simple, guys. B is the most common design motors, the way they designed the slots in the stator. It has a good starting torque and a good air rush, not too high of an air rush, good starting torque. D, now that's B. B is the most common one. D will get you a lot of torque. If you need torque, you have to have a design D letter. B, and C is somewhere in between B and D. Does that make sense? So it has to do how much starting torque you need out of this motor. If you need a normal starting torque, normal speed control, your baby is B. For almost everything that we do, Adam, for all the machines that we do is design B. For certain application, it becomes a design D or design C. It depends if you need more torque out of these equipments. Okay, there are two types of protection, gentlemen. Overload protection. Type number 1 and type number 2. The only difference is very simple. Type number 1, guys, if you have a short circuit condition, your equipment will not explode, but it could burn and deemed unusable. Did you guys hear me? That's what type 1 is. You put a fuse, you have a short circuit, now your controller burned, nothing exploded, just burned, and the fuse interrupted there. You have to go change the controller. That's type 1. Type 2, you have a short circuit condition, your controller will not explode and kill somebody, and your controller will survive to live another day. Meaning, all what you have to do now is go take care of the short circuit, reset the circuit breaker, and push the button and you're up and running. Now, which one do you think is the best? Type 2. What's wrong with type 2? You spend more money to get a type 2. So there's a type 1, type 2 protection. So for example, guys, if you have a VFD and your VFD is $10,000, VFD on a 100 horsepower motor, do you really want a type 1 or type 2 protection? You need type 2. If you have a magnetic starter, big fat boy like this, old contact, nothing electronic, you want type 1 or type 2? Type 1. You can see the difference between type 1 and type 2? How important is the controller? Soft start, VFDs, recommendation type 2. Magnetic starters, recommendation type 1. There's something called industrial control panel, guys. Industrial control panel, that's when they assemble the controller, the overload, and everything else. There is a whole article in any secret book designated to the industrial control panel. Um, if you guys, so here's an industrial control panel. You're looking at it right here. That could be custom designed to be an industrial control panel. So it has the controller, the overload, the overcomputation device, the disconnect sometimes, all grouped in one location. And the NEC code book applies to all of them. A couple of things, guys, about sharing. Adam, the rule when it comes to equipment, guys, is individual dedicated circuit. If you have an appliance or a machine in a commercial industrial building, you give it a dedicated circuit. Now, can you share circuits with lights and receptacle? Yes. Is it a good idea? Absolutely not in a commercial industrial project. Now, what happens if you have a 15 amp and a 20 amp circuit and you need to share light and appliances with it? You cannot exceed the 50% of that circuit. For example, if your circuit is a 20 amp like this, the largest motor that you can put on it is 50% of 20 is 10 amps. You can't put more than 10 amps on a 20 amp circuit if that circuit is shared with other equipments. Any question, guys, about this? I don't like to emphasize that one because we really don't want to do them. We, as engineers and designers, we don't want to do that. Here's what you need to do. This is where the 80% goes. I have a 100 amp circuit and have my machine. Now I can pull 80 amps out of this. 80 amps out of this machine. I can't. That's an individual dedicated circuit, Adam. An individual dedicated circuit. That's what we need to do. We need to provide for all our machines in the commercial industrial an individual dedicated circuit. Any individual dedicated circuit, guys, you can't pull more than 80% out of that circuit. Why? Because continuous load. Continuous load is rated for 80% of what the circuit breaker is. So if my circuit breaker is 100, I can pull 80 amps out of this. 80 amps out of this. The rest of this, guys, talks about equipment in the project that we have. For example, they have a bake oven, and they're powering, and the full load amp of this big oven is 60 amps, and they're powering multiplied by 1.25. They're powering it with number 6, and they're having a disconnect with inside of the equipment. So that's, Brian, is the equipment that they have in this project. If you have conductor supplying multiple motors, you guys remember how we did that? You take 125% and multiply it by the largest motor plus all the full load of all the other motors. You have done that many times with me, guys. So, for example, if you have a machine, Karen, and that machine has 3 motors in it, and you want to have a branch circuit that feeds all these 3 motors because it's running that machine, you take the largest motor, multiplied by 1.25, add the full load current of all these motors, and size your branch circuit. They have to be functionally associated, though. If you have a feeder, now this is not branch circuit, a feeder, the same way, guys. We take 125% times the largest motor plus the full load current of all the other motors. And when we size the overcomputation device, you guys remember, we take the largest overcomputation device of the system plus the full load current of all the other motors, and we go down on the overcomputation device. In a case like this, you can have, of course, overload protection for each and every one of these motors, as well as short circuit. This is just talking, guys, about using disconnect for appliances. The code talks about plug. Here's your disconnect here for the appliances. Cordon plug, permanently connected, and the article that talks about it, the same thing for motors and appliances. So disconnects have to be within sight, have to be disconnect all the ungrounded conductor. If it's not within sight, they have to be locked, and they have to adhere to certain rules. Grounding, these are all the rules for grounding, guys. It tells you your equipment and your appliances must be all grounded. Must be grounded regardless if it's permanently connected or installed. Overcomputation device for equipment. We'll talk about the overcomputation device for equipment, guys. For appliances, this is where it tells you if the amp is equal or less than 13.3 amps. Your overcomputation device is 20 amp. if your amp is more than 13.3 amps, you have to multiply this by 1.5 to size overcomputation device. That's for appliances, unless they tell you otherwise. If you have an appliance, Adam, you're supposed to give it a 20 amp circuit. If you have an appliance, unless they tell you otherwise. If the full load amp is more than 13.3, then you are to for overcomputation device to multiply by 1.5, by 1.5. And we talked about these at one time, rated at more than 13.3. And the overload for appliances, most of the time, guys, will be built right into the appliances. Garbage disposal was not. Equipment. So this is just talking about the equipment that we have there. There's mixers and what's not, and dough dividers and donut machines. These are all appliances that require an overcomputation device, a feeder, as well as a disconnect. Here's the baking oven and the connection for the conductors for it. Here's the baking oven that they have, guys, in this example. They're having, look at this one. They have a disconnect right here within the equipment, an overcomputation device, that fuse right in here. You have your conductors by 1.25. You have conduit, of course, to feed the conductors, and a nameplate that has all the information that you need to size this system. Any comments, guys? Any questions? Any comments? Any questions? So for the most part, Adam, how do you size? You size your overcomputation device 1.25. How do you size your conductors? 1.25. Conduit, of course, based on the conductors. Your disconnect for most of the time 1.15, guys, is my disconnect. All these are the sizes you size it for this piece of equipment. You have an overcomputation device. Controller, where would the controller be? Right inside the equipment. The controller. Right inside my equipment. Okay, let me show you a couple of pictures related to this, guys, and then okay, here's this is really interesting because it's graphic. When you have a disconnect, guys, the disconnect has to be within inside of the controller and the motor and the machine. You see that? So it has to be within sight of the controller, within sight all the controller, the motor, and the machine. The controller, the motor, and the machine. Now, for most of the time, Derek, the controller, the motor, and the machine are one big box. But under certain circumstances, guys, this could be different boxes. Okay, so that's your disconnect. Now, if you can't have the disconnect, guys, within sight of the control in the machine, you are, Adam, to provide two disconnects, one for the controller and one for the disconnect. This is major thing when we design, guys. Major thing. If you controller in one room and your motor machine in another room, you have to have a disconnect for the controller. It's a lot of money, and a disconnect for the motor. Here's an exception, though. This is the exception that a lot of engineers, guys, use. Or the exception is the controller here, the disconnect does not have to be within sight of any one of these. But look at the condition, though. There are two conditions right in here in order to use it. Number one, it has to be impractical to install or create more hazard. You create more hazard, or impractical to install the disconnect. Yep, that's why inspectors will walk in and say, okay, where's the disconnect? Well, it's in the second room, locked. Okay, why did you put it there? Well, it's impractical. Show me why it's impractical, or why it's a hazard. Is it a gas station? You don't want to put it in an explosion-proof area? So that's condition number two. And condition number two, in industrial installation, factories, not commercial building, in industrial installation, where smart people, qualified people maintain and troubleshoot the system. That's the only two conditions, guys, that you have to, if you have, you can put your disconnect anywhere you want in the plant. Anywhere you want in the plant, as long as it's lockable. I can't emphasize, this is the exception, not the rule. The rule is the disconnect have to be within sight of the equipment and the controller. The exception, if you meet these two conditions, you got your disconnect anywhere you want, as long as you lock it. Any comments, guys? This is most commonly confused part. We talked about disconnect can be a snap switch with a controller. These are how we size our overload, guys. Tables for sizing heaters, unit heaters for overload based on the full load current. You can pick if your full load current from this number to this number. You can size overloads for your equipment heaters. This is what happened. This is really nice. If you look at Adam, here's a 10 horsepower motor, guys. Really nice, beautifully looking 10 horsepower motor, healthy. Can you guys see the windings? Nothing is burned in it. The motor is rated for 10 amps, 10 amps, 10 amps. The overload is at 12.5, 12.5, 12.5, 12.5. The fuse is rated for 20 amp, 20 amp, and 20 amp, and everything is heavy, up and running. Okay, can you guys see that? Just look at everything is sized. This is size based. This one will be sized based on 1.25, and this is sized based on 1.75, exactly how we size them. Beautifully sized. Now look what happened if you have a single phase. So I want you guys to look at 10, 10, 10 here. Now the minute that you have, now what happened here is an overload condition. An overload condition. Now this machine, we filled it. Supposed to, guys, say it's an elevator. Supposed to carry 5 people, and we put 10 people into it, and we kept pushing. Now start sucking more current. Remember, it was supposed to suck only 10 amps here. 10 amps, 10 amps. Now what happened to each one of them is pulling 50% more load. 50. If it continues, here's how the inside of your motor is going to do. Completely burned. That's called overload condition. This motor have overloaded and burned. Does that make sense? Overloaded and burned. How do you overload the motor? The mechanical machine on it. You're adding more load on it. Okay, so I want you guys to look at the charted inside of this motor. That's overload. Now look at this condition here. Compare this one to this. Now single phasing. So if you go, can you guys see now Excel? Let's blame Brian. Went and one of their fuses open and the other 2 fuses are still in. Cool. Now look at what happened. This is carrying a 0 amp. This will carry 17.3, 17.3 to compensate for the loss of this amp. Now these are overloaded. If you don't have an overload protection, guys, look what happened. 1 phase will get burned. 2 phases will get burned. Can you guys see that? These 2 phases will get burned, and 1 phase will not. Can you guys see that? These coils are belong to 1 phase. Which phase? That one. So this will burn, this will burn, and this will not. Who cares? If you're working for a winding shop and comes a motor like this for you, by looking at it, you can tell the guy, hey, you have single phase problem. Well, how do you know? Well, 2 phases are burned and the 3rd phase is not. If you have this situation, you can tell him you have an overload condition. How do you know? The whole thing is burned. Does that make sense? Do you guys see how important the effect of burning these motor on? I thought these are, so that's your overload. If it's a delta, same thing, guys. You can see the same thing in a delta or a Y motor. The delta or a Y motor, the same thing. Your motor is going to burn. You can see I have an open condition, 0 amp here, 17.3. 17.3. Remember, this was supposed to be 10. This is supposed to be 10. This is supposed to be 10. Right? Now, when this 10 crossed, that motor said, hey, give me more current. He is asking for current on this leg. This leg say, I can't give you current. So the motor goes and pull current from the other 2 legs. Does that make sense, guys? Pull more current. So the overload protection here, see the overload protection here, should have tripped. Your overload protection is 12.5. You're pulling 17. Within 10 to 20 seconds, the overload should have tripped. If you don't have an overload, that's what's going to happen. You're going to burn your motor. Can you see these coils that's burned? That's single phase condition on a delta motor. Any comments, guys? Any questions? So important having an overload. So how do you prevent from single phasing? Have a proper overload. Have the proper overload. Okay, same thing, guys, could happen in if you have, these are, look at this. I have a transformer, and actually, the open happened on the primary side of a transformer. I have an opening on the primary side of the transformer. The same thing here. The one phase, can you see this phase now is carrying 23 amps, this carrying 11.5, this carrying 11.5. We're still talking about the same 10 amp motor. So one phase here will burn. That phase here will burn. So that's if you have a primary open on the side, on the primary side. Here's what we said, guys. If you have a big fat motor, so that's the effect of single phase single motors. If you have a big fat motor, here's a 10 horsepower, 100 horsepower motor, and here's a 5 horsepower. Can you guys see that? Now, if you have single phase condition, this is a 100 horsepower motor, but we're loading it 50 horsepower. So it's 50% loaded. I have it open, one phase opens. Now, the motor, guys, will generate a second phase. It will generate a second phase. So that phase will be generated right here through the motor, and it will start, a smaller motor on the network will start and run. So who cares? If you guys walk into a plant, you might have a single phase condition without anybody knowing about it. So be aware. How do you verify this? You have to go measure the voltages. Phase to phase, phase to phase, phase. Make sure you have a proper voltages. And measure the current in every phase. Make sure you have a proper current in proper phases. Okay, so that's what weird things happen. Starting current. This is how we represent the start current, guys, in the motor. For only 10 seconds, Adam, only 10 seconds. This is the amount of current that the motor is going to suck. And then after that, it will continue. Can you guys see normal operation? That's called the inrush current. Who cares? Do you guys care? Who cares about the inrush current? You know what happens with the inrush current? The light will dim. You have losses in the lines. Light will dim. It kills your circuit breakers and what's not. So we want to minimize this. The inrush current. This is just a couple of controller for, I think, one of the machines that we're using, guys, there has a controller. It has, I think it's a dome mixer, or it's not. All this is one machine, just to give you an idea how the machines are. It has a motor inside it, and it has a heating element, 3-phase inside it, and it has a bunch of thermostat, temperature thermostat, and what's not. That's how you can get a machine. I can't remember if this is the dough mixing machine or one of their machines that they're using. Just to give you an idea what an appliance would look like inside the appliances. Okay, so this happened to be a control wire for, the donut. This is the donut machine. So you need a heating element for your donut machine, and you need to mixer and heat and what's not. All this thing, we don't get involved in it, Adam. We don't design the inside of it. What we get involved is right in here, guys. Right in here, we have to provide a disconnect to the machine and an overcome protection device and a feeder, right? Inside the machine, designed by others. Doesn't mean we don't know how it works, but it's designed by others. Okay, so we talked about this one, guys. This is the same donut. We are having a branch circuit coming to it, a disconnect, an overcome protection device, a conductor, a conduit, of course. And here's what the nameplate has. It has volt, amps, watts, minimum circuit conductor, maximum overcome protection device. So almost all the machines, guys, will give you the manufacturer of the machine. Will give you these two values. They will give you the minimum circuit conductor, that's the conductor size, and the maximum overcome protection device. So in this case, I think that was number 6. And number 6 conductor, is that what we did? Number 6 conductor. And that was 60 amps. Number 6 conductor and 60 amps. Right on the nameplate of these appliances. So you don't have to do anything. If you don't have this info, you just multiply 1.25 and you can get it for the conductor and for the overcome protection device. For the conductor and for the overcome protection device. Okay, so let me skip. I'm almost done with that one, guys. Okay. So that's my my equipment. This is just a circuit breaker, guys. I don't know if you see Adam here. This is how they had disconnect, permanently installed disconnect in panels. That will qualify as lockable disconnect. They have a little mechanism on them where you can lock them in the open position, commonly used. Controllers. Um, okay. Here's your overload, relays and what's not, your overload heaters. Here's completely burned motor. You can see that winding has been burned. We talked about all these guys, single phasing, all these motors. Fuses, different type of fuses that you can use for them and different machines. What I want to emphasize for the project that we have, guys, this is electrical values for electrical water heaters installed in a commercial building. These are all electrical water heaters. I want to bring to your attention this factor. Isn't that the magic number? 125 to size the conductor and the overcome protection device. Can you see that? For all of them. Take the full load amp, multiply by 1.25, size everything. For the most part. Overload, these are guys directly from the code. If your service factor is less than 115, not less than 115, 125, temperature rise not over 40, 125, all other conditions are 115 directly from the code, and we use them. Here's the insulation type. Insulation D can get you 180 degrees Celsius. That's the wire. So if you want a motor that's going to be abused in a hot environment, Karen, you're going to specify a motor with insulation D. Typically, we don't specify motors, so but be aware of that one. Here's what happens, guys, when the voltage goes up or down in the motor. Look at that, 10% higher, 10% lower. If 10% higher, full load current decrease 70%, starting current increase, temperature rise, decrease, and the full load speed increase. If you reduce the voltage, look what happened. The full load current will increase because we will compensate for that. You decrease the starting current, the temperature increases, and the speed decreases. So these are the effect of reduction in the voltage on the speed and the temperature and what's not. Both of them are bad news. As long as you stay within plus or minus 10%, guys, on the motor, you're good to go. You go higher than that or lower than that, you burn your motor. In summary, percentage of unbalance, derate the motor. They recommend, guys, if your voltage is unbalanced 5%, you're supposed to derate the motor down to 75. Now, if your motor is 100 amp, you're supposed to get only 75 amps or horsepower out of it. These are loads and fuses that you can size for them. Different type of fuses used as an overload. You can use a fuse as an overload, guys, and these are different sizes for different application of fuses. This is the overcome protection device. I have never, and I taught this one many times, guys, I've never seen a table nicer than this. For example, an untimed delay fuse. Your multiplier is 300%. If your motor doesn't start, you can go up to 400. Non-time delay fuse, your multiplier 300. Same thing, 300 if it doesn't start. Time delay, dual element time delay fuse, guys, 175. Go up. If it doesn't start, go to 25. My favorite is inverse type circuit breaker, full load amp 100 or less. You can go all the way up to 400. Anyway, so this will give you the maximum overcome protection device on motors. And if they don't start, they allow you to go even higher than that. All directly from the code. Design A, B, and C, a difference between the design of a motor. I want to bring to your attention, guys, the most common design that we use is design B. It has a starting torque low, which is good news. A lock rotor current or torque, start torque is high, so good torque on it. And application, look at that, blowers, fans, compressors, and that what you guys, conveyors, that's everything that you do. So this is basically what we use all the time. Design D, look why they use design D, guys, and cranes, punch machines, shears, cutting through things. You need a lot of oomph, a lot of torque. Can you guys see that? Very high torque on it, very high torque. Low starting current, very high torque. Adam, the good news is, You don't specify these guys. The manufacturer will specify the type of the machine. If it's for us engineers in buildings, we almost always deal with a B, a design B motor. But if for certain applications, you can go D. What does D do for you? Man, God, they can. If you have a 1-inch thick steel and you make a hole in it, you have a machine with a motor and bang, it hits it and it makes a hole into that one. What type of motor you want to drive that machine? It will be design D, not B, not B. D is the torque, give you a lot of torque, not a whole lot of rotation, but a lot of torque. So that's a major thing, guys, when it comes to these machines. These are just the mixers and what's not, and that's about it in terms of motors. Any comments, guys? Any questions? Any comments? Any questions? I can't emphasize, guys, please go over this one. I don't have calculation for you because we did them last project. Next project, Derek, my friend, we're going to be doing all these calculation again. So we'll just do for the industrial project. So but if you know it now, you're good to go for next project. And we've done it the project before. So my plan is not to do a lot of calculation for it. We did it last project. This project we're going to focus on lighting, and next project we'll do it one more time. Before I leave, any comments, any questions, guys? Comments, questions? Okay, that's all I have for you guys. Just a quick reminder, please do not leave today without printing your power layout wherever you are. If you're done with your power layout, please start your lighting. Lighting will take time, guys. So start your lighting calculation right away. Thank you.